Okay, today we're going to talk about the law of cosines, and our objectives are first to use the law of cosines to find unknown parts of the triangle. We're going to do that later in the lesson. And primarily we want to determine when to use law of sines or law of cosines. That'll be the first part of the lesson, and then we're going to use law of cosines to solve some real world problems. All right, so I'm going to have you guys draw this diagram on your own, and you're going to work along with me. There's going to be some classwork which is not going to be assigned, but I'm going to ask you to work through the problems with me so that you can see for yourself what the problems are inherently with using the law of sines for any of these types of triangles. So you recall from the last lesson, we had the different congruence postulates, and so I'm setting these up as a type of triangles in what you're given. So SAS means side, angle, side, meaning you're given a side, an included angle, and a side. And then you need to solve that triangle, meaning find all the measures of all the angles and sides using those three pieces. And you can use either the law of sines or law of cosines. And you're going to find out that one is going to be better than the other depending on what you're given. All right, so let's kind of go through what we learned in the prior lesson on the law of sines. So law of sines, sine A over A is equal to sine B over B, sine is equal to sine C over C, where the uppercase is the angle measure and the lowercase is the side length. All right, so now I'm going to ask you to work along with me. I'm going to give you the answers, but you can pause to use the law of sines for a triangle in which you're given an angle, a side, and an angle. So take a moment here, you can pause this. I'm going to move forward to give you the answer, and you're going to see if you can solve this triangle, ASA triangle, given angle, side, and angle, included side, between the two angles, and then we're going to move on. So take a moment here to solve this. All right, so you should be able to solve this triangle with these values, not a problem. So we're going to go to our, and again, you can pause this to look at my work. We're going to go to our table, and we're going to acknowledge that we can use the law of sines to solve angle, side, angle triangles. And so we're going to mark that with a check. That is one of the ways that we can solve angle, side, angle triangles using the law of sines. Okay, so now we're going to try angle, angle, side. So you can pause here and copy down the information and do your work to see if you can use the law of sines to find the missing angles and or sides to solve this entire triangle. So you can pause here to do that. I'm going to give you the answer. All right, so yes, you can solve angle, angle, side triangles using the law of sines. Here's my work. And so I'm going to go back to our table, and you're going to check out angle, angle, side. All right, now we're going to go to angle, side, side. And of course, this is called the ambiguous case, as we discussed before, which means there's a possibility of no solutions, one solution, or two solutions. And so you guys can solve this one as well. You can pause this, taking down the information for the triangle. All right, and then we're going to end up with two sets of possible triangles. For angle B, 56.4 or 123.6, angle A, 93.6 or 26.4, and side length A, 12 or 5.3. So you need to be careful again when using the law of sines to solve angle, side, side triangles, because you can end up with 0, 1, or 2 answers. All right. So let's just say that use caution when using law of sines for angle, side, side. And so we're going to put a little asterisk next to our check, and we're going to move on. All right, you can do this problem as well, and I'm going to give you the answer. There's only going to be one solution in this case. And all right, so now we're going to move on to side, side, side triangles, and let's see if you can solve this side, side, side triangle using the law of sines. You can pause here to copy this down and do your work. And you're going to realize that you cannot solve a side-side-side triangle solely using the law of sines, because we need to have one defined ratio. In this case, we don't have any defined ratios. Sine b over 7 is equal to sine c over 19 is equal to sine a over 15. There's no ratio to equate some other values to. So we cannot use law of sines to solve side-side-side triangles. So we're going to go back to our table. Then we're going to write in no next to the side-side-side triangle in the law of sines in the table. And now we're going to try side angle side. I'm going to have you pause here for a moment. So I know there's a lot of back and forth. I would really like for you to make the attempt to try to solve these as we go through this, even though I'm not going to grade your work. So let's see if you can solve this triangle using the law of sines. Go ahead and pause. All right, and you're going to see that again, once again, you can't use the law of sines to solve a triangle in which you have a side, included angle, and a side, because again, we don't have a defined ratio. All right, so that completes the left-hand side of our table for law of sines. So let's talk about the law of cosines. First, I need to give you the formula for the law of cosines. If you want to, I have put together a proof for the law of cosines. It's at the end of this lesson, which I'm not going to review in a video format, but you can consult the PDF version online for this lesson if you are interested. The book also goes to the proof for the law of cosines. So I'm just going to go ahead and give you the formula. C squared, so these are lengths. C squared is equal to A squared plus B squared. So remember, lowercase values of the side lengths. Minus 2 times A times B times cosine of C. So then B squared is equal to A squared plus C squared minus 2AC cosine B. And then finally, A squared is equal to B squared plus C squared minus 2BC cosine A. So you can memorize this. There's a pattern to the law of cosines. I start with the side length as the value I'm trying to define through this equation. I'm taking the other two side lengths, taking the sum of the squares of those values, and subtracting 2 times each of those side lengths, the product of those side lengths, times the cosine of the angle that is across from the side length that I'm trying to find. Anyway, you can look through the pattern and figure out your own way to memorize this. You will be asked to memorize both the law of sines and cosines. All right, so let's go back to our table, and we're going to use the law of cosines to find the missing side lengths. And you can just solve for C if you want. We're just trying to see if this is possible instead of going through the law of cosines to find the angles, all three angles. So I'm going to pause here. You're going to do the work, and I'm going to show you that C is equal to 114.5 degrees. So let's recall from where we were discussing possible angles and reference angles. We see that when we go through the evaluation, filling in the values for the unknowns and then solving for cosine of C, we're going to take the inverse cosine of negative 0.414, and we end up with an angle measure that's 114.5 degrees. In the law of sines, sometimes you might find your reference angle or an angle that's in the fourth quadrant is a negative value because we're calculating the principal values. Although that's not an issue here for cosine. You have to be aware when you're solving for an angle measure that you're getting the principal value. And so it's always important to construct your diagram just to verify what values you're getting as relevant values in this case. We don't have to worry about that with cosine. All right, so we realize that we can use law of cosines to solve side-side-side triangles. So we're going to go ahead and mark that in our table under law of cosines. And you can see how this lines up nicely, at least with respect to side-side-side triangles. And now we're going to try side angle side. So let's just find the length of B in this case. You can pause here to take down the information. And you're going to see that you're going to get 9.32 when you do the work, and you can see my work here. And so we're going to acknowledge that we can use law of cosines for side angle side triangles. So we're going to mark that here. Again, you can see where law of sines, we cannot use law of sines for side angle side or side side side. So we're going to use them for, we're going to use law of cosines to solve those triangles. All right, next one, angle side side. Let's see if you can solve an angle side side triangle using the law of cosines. And we're going to end up working on evaluating a quadratic, and you can come up with a value for A using the quadratic formula. And many of you could have come up with it, but I stopped here just because the effort that goes into trying to solve using the law of cosines for angle side side is too much. So I'm going to say don't use, you can, but it's going to take you longer to solve angle side side triangles using law of cosines than it is for you to use the law of sines. So you use law of sines for angle side side, even though it's possible to use the law of cosines. It's just too much work to solve, and I'm not going to go through that work for you right now. So we're going to say yes, but it's not the easiest path. So let's take the law of sines as the path to solve angle side side triangles. And then we're going to look at angle side angle. So pause here. Let's see if you can do the work to solve. And you're going to see we're going to end up with two unknowns, A and C. And so we're not going to be able to solve for angle side angle using the law of cosines. So we can't do that. We have two unknowns. And so we're going to write down no. And then the last one, angle side. You can pause here to see if you can solve this one as well. You can just solve for A or B lengths. And you're going to see again we have two unknowns. So we cannot use the law of cosines to solve for angle side. So going back to our table now, I added another negative to the angle side side. So we can't use law of cosines for angle side angle or angle side. So we have two A's, no law of cosines. We have side angle side and side side side. We can't use the law of sines. So you can see how depending on what case you have for a triangle, you're going to use either law of sines or cosines. Law of sines, angle side angle side side with caution. And then law of cosines for side angle side and side triangles. All right, so it's time for some classwork. I'm going to give you some problems, and we're going to have to break this into two, we might have to break this into two videos. Actually, I'm going to give you a applications problem, and then I'm going to stop, and then I'm going to give you a bunch of problems for classwork. All right, two airplanes at points A and B have elevations of 26,000 and 17,000 feet respectively. Both are flying east toward an airport control tower at T. So here is the airport control tower. From T, the angle of elevation of airplane A is 5 degrees. So this angle here is 5 degrees. So that's the angle in blue, as you can see here. From T, the angle of elevation is 5 degrees, and the angle of elevation to airplane B is 2 degrees, so this angle in red is 2 degrees. How far apart are the airplanes? All right, so let's go to the solution. Let's see if you can work this out. This is not classwork, but let's see if you can work it out on your own, and I'm going to go through the solution. If you want to pause here, you can work it out. All right, so we're going to see that the angle side is a type of triangle that we're going to try to solve, because I have a right angle here and here, and I have two angles here, and then I have a side length here. All right, so I only have about 10 seconds to give you this answer, so you're going to have to interpret this because I got to cut my video to 15 minutes, and you can look through the work here, and that's it.